Hi everyone, I'm Dr. Shrija, Associate Professor from the Department of Artificial Intelligence and Data Science. So in this video, we are going to learn about the subject Automata Theory and Compiler Design. So the objective of learning this course is to introduce the fundamental concepts of Automata Theory, to understand about DFA and NFA, to elaborate on regular expression and grammars, to introduce push-down automata and Turing machine, to introduce the major concepts of language translator and compiler design, and to elaborate the code optimization and code generation. Upon learning this course, the outcome of the student will be able to construct an NFA and DFA, and the student will be able to design the context-free grammar, and then the student will be able to design a syntax analyzer, and the students will be able to design a symbol code generator. So in this video, we are going to see the topic Introduction to Automata Theory. The finite state machine is also called as the finite automata. The finite automata is divided into two: the finite automata with output and the finite automata without output. Further, the finite automata with output is divided into Moore machine and the Mealy machine. Finite automata without output is divided into three: deterministic finite automata, non-deterministic finite automata, and epsilon NFA. The DFA, deterministic finite automata, have some important properties. The first property is it is the simplest model of computation, and also it has a very limited memory. So these two are the basic properties of DFA. Now we can move on to the representation of DFA. So this is the structural diagram that represents the DFA. So by referring this diagram, we can see that there are various states. A, B, C and D are the various states. We can see the transitions from one state to another. So the transitions from one state to another is indicated by some edges, and the value in the edges represent the input value. So here we have 0 as the input value and 1 as the input value. We will call it as the alphabets. From this diagram, we need to identify the source and the destination. The source and the destination. The source is also called as the initial state. So the input from nowhere. So this is, we will call it as nowhere. The input from nowhere is called as the initial state or the start state. This double circle state is denoted as the final state. So in this example, we have four states: A, B, C and D. So this is the representation of DFA. The DFA have five tuples. Q is the set of all states, that is A, B, C, D is the set of all states. Then sigma is input. So here in this example, we have the input value 1 and 0. Then Q0 is the start state or the initial state. F is the set of final states, and delta is the transition function that is mapped to Q. This is the representation of DFA. Now we can see the transition table for the example. So here we have the example, and I said already the tuples of DFA. First we will take the tuple Q. What are the values for Q? That is the number of states. So A is the state, B is the state, and C is another state, and D is another state. So we have represented this. Then sigma. Sigma is the input. So in our example, the input is 1 and 0. So we have represented as 1, 0 and 1. Here Q0. Q0 is the initial state. Here in this example, A is the initial state and the final state is D. Then we have to calculate the delta also, transition. So for calculating transition, we I am representing it using a table. So we have the states A, B, C and D, and we have two inputs 0 and 1. State A, by taking the input 0, it will move to state C. Likewise, state A, by taking the input element 1, it will move to B. Then state B, by taking the input element 0, it is moved into state D. B, by taking the input element 1, it is moved into state A. Likewise, C, by taking the input element 1, it is moved into D. By taking the input element 0, it is moved into A. D is the final state, and D, by taking the input element 0, it is moving to B, and by taking the input element C, by taking the input element 1, it is moving to C. So this is the transition table for the given example. Thank you.